Mic check, mic check. 1, 2, 3. This story chronicles the conquest of a college student grappling with the numerous trials, embarking on a journey to conquer and overcome them.
Mo gusto daw grades AVTE.
Oh, wait. Ano yung grade mo?
125.
Ay, may nagmuna ako. Wait lang.
Pre, huwag ko na mag-grade product ko.
Walang sa akin, nagpunin ako sa test ko. 1.25.
Grabe! Ako 1.5. Daya. Ante.
1.5?
Oo.
Bago ko.
Pero sinabi ko, pero that means pa lang sinabi ko na hindi ko ano. Tapos sinabi ko na yung grade ko. Biglaan.
Hindi, sige ako lang yan.
Hindi. Pangit.
Hindi. Ano na ba nangyayari?
Kwatro ko, di ko alam paano nangyari yun. Ba't ganito? Ginawa naman lahat ng kaya ko. Babalikan ko ba ang oras na sayang ulimutin lahat ng pagod ko? Gusto kong mag-aral ng mabuti, hindi katulad nung dati walang tumatatak sa isip ko. Paano yan? Hindi ko nga alam. Alam mo, kailangan mo ng diskarte para dyan. Yung di kasi lahat ay puro aral lang, no? Kailangan mo na ng diskarte din sa buhay. Pero marami kasi iba't ibang uri na diskarte. Pumili ka kung anong bagay sa'yo. Diba? So now, masasabi ko lang yung 4 mo, syempre diba, malaking bagay yun. Ako rin, naka-4 din ako. Pero, I never give up naman to try eh. So, I try naman, nakabawi, as long na nahanap mo yung rason kung paano ka nagkaroon ng 4. So, masasabi ko lang, ano yung pagkukulang sa'yo? Diba? So, masasabi ko lang, it's okay not to be okay. Right? Kasi, pagtanda mo din, magiging unfair din ang buhay eh. Pero, since hindi naman lagi unfair ng buhay, as long na may kaibigan ka, may kasama ka, pwede kayo mag-study group or banta man lang, kahit anong kanta, kung trip nyo. So, kung nag-4 ka ngayon, pumasa ka, balikan mo rin yung pinagdarasan mo para ma-motivated ka sa mga bagong hinaharap mong hadlang, diba? Kung binibigyan kang chance na ni Lord or may scientist na nakagawa ng time machine para makabalik sa nakaraan, sinong gusto mong kausapin? Sino gusto mong tanungin? Invento niyang mga ewan ko na yan. Di naman sa ewan yan, diba? Normal lang naman magalit, pero kasi kung pinag-isipan mo mabuti mga bagay na nangyari sa'yo, low-key na parang isang blessing in disguise lang na nakabuti din para sa'yo, diba? Tama nga naman. Mahilig ka ba sa electronics?
Medyo po.
Kung gusto mo talaga, may paraan. Kung wala, ayaw. Pero sige, hanggang dito lang ako.
I am so sorry, Mr. No, I'm not here, right? Wait, where am I?
Sky, wait up!
Oh, Sky, who's this imbecile? I'm sorry, mister. I just failed my exam class and feeling down lately. I don't know what to do.
Ah, the ups and downs of academia. Don't not worry, my child. We have all been there in our time.
Indeed, learning is a process full of obstacles, but it is how we overcome it that will define us.
Here, here.
Tell us, my friend, what specifically are you struggling with? Perhaps we can offer you some guidance. I just couldn't get a grasp on concepts like valves and tubes.
Don't worry, we will find a suitable place for struggle to top.
Come, let's go, my friend.
So, shall we begin? Can you discuss me about valves and tubes?
Valves, let me discuss with you the precursor of the vacuum tube. So,
This is a diode. Fundamental operation, it presents an ordinary single pole switch. A switch that can connect, for instance, this battery and its motor. One power LED comes from to the anode and the other LED goes to the cathode. When this switch is open, the contacts are insulated from each other by a vacuum or by some inert gas inserted into a evacuated tube under low pressure. To close this switch electrically, all we need to do is hit the cathode and give the anode a positive potential. Then here's what happens as electrons are emitted. From the surface of the heated cathode being negatively charged, they fly at a tremendous speed. In this way, a current path is formed, which closes our electronic switch and permits our motor to operate. You'll notice, by the way, that the direction of current flow is contrary to the orthodox concept of the current flow. From plus to minus, in the first place, we can rectify current with it. AC to DC. We can do this merely by connecting an electronic tube in series with an AC circuit. As you study the circuit diagram, note that only each positive half wave of AC voltage will now produce a current. When this anode is negative, the electrons are repelled and no current flow. In other words, it's only the cathode can emit electrons. We have here what amounts to a one-way street. We can visualize the result of the tube's rectifying action with the aid of this two oscillation scope. The one on the left shows alternating current coming in. The one on the right shows pulsating direct current going out. The application of this basic rectifying principle are many. And important, the second basic thing we can do with it is amplify. Here's how between the cathode and the anode of the two elements to which we diagram place a grid. To this grid, we can connect an input of some weak voltage which we wish to amplify, perhaps out of a faint radio signal from halfway around the world. Now let's see what happens. Every time a negative potential is impressed on the grid, even though it be very minute, it has a large effect in reducing the number of the negatively charged electrons, which will otherwise keep flying from cathode to anode. Conversely, when the grid is positive, an equally large effect is exerted in increasing the flow of electrons from cathode. You know that the important thing to know that there's this a small amount of power applied to the grid is amplified into a large amount of power in the AND or work circuit. This amplifying property of the three-element electronic tube is put to work in a memorable way.
So that's it.
Now let's talk about triodes.
The triode closely resembles an indirectly heated diode with a filament heating a negatively charged cathode and a positively charged plate. Unlike the diode, the triode includes an additional element called the grid, positioned between the cathode and the plate. Electrons emitted by the hot cathode are attracted towards the plate, but the electron flow to the plate is controlled by the charge applied to the grid. A sufficiently negative charge on the grid stops electron flow, while a more positive charge increases electron flow. Despite the plate being at a high voltage ranging from 24 volts to 300 volts or more, the grid can control this with a much smaller voltage, typically between negative 10 volts and 5 volts. For instance, a 6DJ8 dual triode can adjust the LED brightness based on the grid input. A graph illustrates the correlation between output voltage and grid voltage in an inverting amplifier triode. As grid voltage rises, more electrons flow, reducing the plate potential.
And that's what you need to know about triodes.
So now, for the improvement of the triodes, I invented tetrode.
When two metals are near each other, there is some capacitance between them just like in the triode. This capacitance produces oscillation due to high frequencies. The tetrode's invention gave a considerate improvement in this performance. It is composed of the plate, control grid, cathode, heater, and the screen grid. All components were already present before except for the screen grid. The function of this grid is to reduce the capacitance and hence improves the feedback. It operates at a fixed positive potential, but this potential is below of the anode. The tetrode would now help in improving the performance of the vacuum tube.
And that's all for tetrodes.
And lastly, my contribution, the pentode, which revolutionized electronic amplification.
So far, we've covered the diode, triode, and tetrode. A diode has two active elements, the cathode and the plate. The triode has a third active element, the control grid. And the tetrode has a fourth active element, the screen grid. The next logical step is pentode, giving us the pentode. When the electrons are screaming towards the plate, they sometimes strike the plate so hard they knock neighboring electrons off of the plate. This is called secondary emissions. In the tetrode, this can be absorbed by the screen grid, causing instability and oscillations. In a pentode, a suppressor grid is added between the screen grid and the plate and given a low potential, often by being tied to the cathode. This prevents the secondary emissions from going anywhere, allowing them to be collected by the plate. Pentodes are very stable, have a higher current output, and have a wider voltage swing. Here is a 6AU6 pentode being used as an inverting amplifier. The plate is tied at 24 volts to a 10,000 ohm resistor. The screen grid 10 to 24 volts to a 100 ohm resistor, and the suppressor grid is tied to the cathode.
And I think that's all you need to know about pentodes.
Wow! I've never realized how interconnected these concepts are. I mean, they've shaped the whole field of electronics. I mean, thank you everyone for imparting your knowledge to me. I really appreciate it.
What will that is midterm for? Pre, gets mo yung ano, rectifiers? Hindi ka, naku, mukhang delikado this midterm.
Kawawa ka.
Pre, gusto mo mag-aral mamaya?
Easy.
Tara, aral tayo mamaya. Discord. Ganito na lang mamaya din.
Okay, let's grab our notes and pens and let's go dive right in to a world of circuits where the rectifiers are in. We'll talk about rectifiers, oh, they're quite a thrill. Turning AC to DC with a new feel.
First of all, what this root means, where is the actual useful voltage standard way of measuring, reporting AC voltage?
Now let's go to
Types of rectifier circuit, halfway full with let's explore. To the limit, exploring true and true.
halfway black away, touching into the shore. Capturing peaks, giving so much more. We only get half, the rest is always dead. After full rectifier sees the deal. Another diode added, this is real. In terms of biasing, they're both opposite. Yes, it's true. Rectifier is so fun. Rectifier is so dull. Rectifier is our guide to reach new heights. Learning's never been more fun. Rectifier is so fun.
There's another type of full wave rectifier. Who can guess? Go, maybe you would like to try and answer with success.
In full wave bridge we have 4 diodes, which makes it unique.
Sure is that go, we couldn't be any prouder.
And you gotta believe in something. So today I believe in me, and I came through, I made it. I've never been so proud. I know at first it seemed implausible, but we accomplished the impossible. Now there's something I've got to say out loud. Talk about the root mean square of each wave.
That's it.
Or have we rectify 141?
He's got it.
And in full wave 0.707.
Just he's got it.
Now let's move forward to the frequency.
Sure.
One cycle's done in 8.33.
That's in milliseconds.
The output waveform is 120 hertz. Yes, that's true.
Rectifier is so fun. Rectifier is so dope. Rectifier is our guide to reach new heights. Learning's never been more fun. Rectifier is so fun.
Parang sa Discord ay umikilig na tao, tulog na ako. Ano siya tapos siya?
In this crash course video, we embark on a comprehensive exploration of transistors, pivotal components shaping the landscape of electronics. Our journey begins by unraveling the essence of transistors, versatile devices endowed with the dual prowess of circuit control and signal amplification. Diving into the intricacies, we acquaint ourselves with the bipolar transistor, a cornerstone of electronic engineering. With its 3 essential pins, emitter, base, and collector, we decipher the nuanced roles each plays in the transistor's operation. By manipulating voltage at the base, we unravel the transistor's ability to regulate current flow, illustrating its pivotal role as a switch in electronic circuits. Venturing further, we traverse the dichotomy between NPN and PNP transistors, meticulously dissecting their distinct configuration and underlying current pathways through lucid explanations. We demystify the enigma surrounding electron flow and semiconductor doping, laying bare the intricate craftsmanship that underpins transistor engineering. Delving deeper into the heart of transistors, we navigate the intricacies of forward and reverse biasing, unraveling how these fundamental principles orchestrate the EBB and flow of current within the transistor. With adept clarity, we illuminate the path towards understanding how transistors serve as a linchpin in myriad electronic applications, from basic circuit control to sophisticated signal amplification. This crash course serves as a beacon of enlightenment, distilling the complexities of transistor operation into digestible insights. Through meticulous exposition and illustrative examples, we empower viewers to grasp the essence of transistors, laying a solid foundation of further exploration in the realm of electronic engineering.
For your examination, Mr. Manos, can you lock the back door? And not everyone put your things in front in here in 3 minutes, only one person per table.